Bismillahirrahmanirrahim. Assalamu alaikum, dear all. This is Zakirullah, lecturer medical laboratory technology. Today we will learn about the next step of histopathology laboratory, that is the tissue processing. How will we process a tissue in histopathology laboratory? The aim of processing is to provide tissue a sufficient rigidity so that after processing it can be cut into thin sections with the help of microtome, and that section they will be feasible for microscopic examination. The tissues must have a suitable hardness and consistency when it is presented to the microtome to cut that tissue into thin sections, and this processing it is done with the help of infiltration and impregnation, and surrounding the tissue with the paraffin wax or celluloidine or low viscosity nitrocellulose. It is also done with the help of resin or by freezing the tissues. There are different stages of the tissue processing, and it is a long procedure, almost takes about 24 hours to process a tissue. In the tissue processing there is a carriage system which is used to carry the tissue throughout the different steps of the process from one jar to another jar in the processing machine. Initially, during the gross examination, a small representative piece is taken from the whole organ or from the biopsy specimen, and multiple specimens are taken and then they are put into a plastic cassettes. These are the different plastic cassettes in which small representative pieces are taken, and then these are labeled with the number and the tissue. The cassettes which having small representative sections of the biopsy, they are then placed in this metal container which have perforated walls, and this is placed in this another glass container so that it is transferred from one step to another step during the processing. All the tissues they are properly labeled before the processing, because labeling is important, and an ordinary ink should not be used for the labeling purpose, but a printed page or a graphite pencil, it is written on the cassettes, and typewritten or India ink written labels are satisfactory. Tissues that are fixed with osmium tetroxide, they should be labeled on jar, because mostly the labels they are turned black with osmium tetroxide, so they are labeled above the jar. And the label it should be clear and it should have all the important information which is necessary for the processing. These are the designs of different tissue processors. Tissue process can also be performed manually by taking and by moving the container from one region to another region by hands. The agitation it is also done manually, but the automatic machines they complete all the process by mechanical controlled devices. The principle of processing is to remove the water from the tissue, and then another medium that is impregnated in the tissue which provide sufficient support so the tissue become hardens. And this removal and this impregnation this is done in different stages. First, in dehydration, the water molecule is removed. In the clearing, the dehydrating agent is replaced with the clearing agent, and in the impregnation, the tissue is infiltrated or impregnated with a supporting or a wax. In the dehydration process, the water is removed because water is insoluble in wax. For that purpose, dehydration is a must, so as to put and to infiltrate the wax in the tissues. Clearing is the second step in which the dehydrating agent it is cleared from the tissue, and it is done to facilitate the stage of transition of dehydration and to activate and to start the stage of impregnation. The clearing substance is usually soluble to both the dehydrating agent and as well as the impregnating medium, which is usually paraffin wax. The third stage is infiltration and impregnation, in which the tissue is impregnated with a supporting medium, the paraffin wax, which is suitable to provide adequate rigidity of the tissue to make thin sections. Certain factors which affect the process of tissue processing, and one of these is the size of the tissue. That the smaller the size of the tissue, the better will be the processing. And the second factor is the agitation. The agitation, it facilitates the contact of the tissue with the fresh solution, and it helps removal of water. The heat increases the better penetration of the fluid. Viscosity also affect the process of tissue processing. The higher the viscosity of the medium, the lower will be the penetration, and the lower the viscosity of the medium, the higher will be the penetration. And the negative pressure which is created in the jars, it removes the trapped air from the tissue, and it also removes the clearing agent by increasing its volatility. So the first stage of tissue processing is dehydration. Every tissue, we know that it contains some amount of water, which is either in the free form or it is bonded to other molecules. For successful impregnation, it is required to remove all the water, because the water is not miscible and not soluble within the wax. The dehydration process is done gradually from the lower concentration to the higher concentration using the dehydration fluid, because when there is a direct contact of high concentration of dehydration fluid, this difference of the concentration gradient, they can be squeezed and their size can be shrinked. The smaller the size of the tissue, the better is the infiltration of the embedding medium. The optimum thickness for a tissue, it should be around 3 to 4 millimeter, or the maximum it should not more than 5 millimeter. The thin slices of 2 to 3 millimeter tissue needs less time in dehydration fluid than the 5 millimeter tissues. So the size of the tissue, it should be less than 5 millimeter to make the process fast, and tissues should be kept in the dehydration fluid for optimal time. For example, the small tissues, they take short time, and the large tissues, they take maximum time. Time management for a tissue is important, because when we give too much time in dehydration fluid, so the tissue may become hardened and it may becomes brittle, or when we give a short time or insufficient time, so the dehydration process, that will be incomplete and the water may retain in the tissue. So this should be noticed. For routine processing of the tissues, the following different concentrations are used for dehydration of the tissues. The first step is the 70% alcohol, that is methylated spirit, and usually it is done for 1 hour. And then for 90% alcohol, it should have 2 changes for 2 hours each container. And a pure alcohol, it also called the absolute alcohol, it also should have 2 changes and 2 hours for each container. The process of dehydration is helped by agitating the tissues, and if the tissues are not agitated or slightly and gently vibrated, then it may take longer time than 2 hours. In absolute alcohol chamber, a layer of anhydrous copper round about 0.5 to 1 inch, it should be separated by filter paper. This layer is helpful in increasing the lifespan of alcohol for better dehydration, and when a change of alcohol is required, so this help as a good indicator for alcohol change. The different dehydrating agents which are used in the histopathology laboratory for tissue processing, the most important one is ethanol or ethyl alcohol. Usually alcohol are used as a dehydrating agent in the laboratory. Along with alcohol, other chemicals are also used for dehydrating agents. The important one is the ethanol or ethyl alcohol. This is the most popular and most commonly used, and it is a clear fluid, and it is a colorless and a flammable, very much in a flammable fluid. And relatively, the mode of action of ethanol is very fast. It acts very efficiently. However, sometimes it is difficult to purchase from the local market because it need a government license to buy alcohol from the market for the laboratory purposes. For delicate tissues, the dehydration it is may be started from 50% or it may be started from 30% and then increasing the concentration of the alcohol. Methylated spirit is another type of dehydrating agent, also called denatured alcohol. It contains about 99% of ethyl alcohol and 1% of methyl alcohol or also propyl alcohol. So it also have almost the properties of ethanol. Methanol is sometimes also used as a dehydrating agent. It is a colorless clear fluid, volatile and inflammable, and it can be used as a substitute of ethanol in case if there is insufficiency or a shortage of ethanol or the ethanol is not available, so we can use methanol in the laboratory for dehydrating agent. One of the drawback of the methanol is it is a very volatile and it is an expensive dehydrating agent, so we use methanol very rarely. Isopropyl alcohol is also used and available as isopropanol 99.8% concentration, and it is soluble with water and also with liquid paraffin, so it is also used. It have a good and fast action, a non-toxic dehydrating agent, and causes the minimal tissue shrinkage. It also have a good dissolving properties in the lipid. This is the comparison of different dehydrating agents which are used for dehydration in the tissue processing. This contains all the alcohol and the non-alcohol agents. Ethyl alcohol, it have the advantages that it is a very rapid action and efficient dehydrating agent. The disadvantage is that needs license from the government and it is inflammable. When it is kept for a long time, that it makes the tissue very brittle and hard. Methanol is also used as a dehydrating agent and it also have rapid and efficient dehydrating property, but the disadvantage is that it is a very volatile and costly. Another type of alcohol, isopropyl alcohol, it also have rapid action. It is a non-toxic and it does not causes the tissue shrinkage, but the limitation is that it is not possible to use in Saladin technique. The dioxane is another type of dehydrating agent, a non-alcoholic dehydrating agent. It have the advantages that its action is very fast and it does not causes a shrinkage of the tissue, but the problem is that dioxane, it is a very high and a highly toxic gas is generated in the reaction to the dioxane. The ethylene glycol, it is also rapid action. No graded solution is needed to add with the ethylene glycol, and tissue can be kept in ethylene glycol for a very long time. The problem is that it is a very expensive and another clearing agent is required. Acetone is also used as a dehydrating agent. It also have the fast action, cheaper than ethanol and good for fatty tissues. But the problem is that it quickly evaporates, it is inflammable, and prolonged use may cause shrinkage and brittleness of the tissue. So this is the comparison among the different dehydrating agents used in the histopathology laboratory. This is the summary of dehydration process, that what is the purpose and how much the concentration is used for in the routine laboratory, the common dehydrating agents. The second step in the tissue processing is the clearing. The clearing is done for removal of dehydrating agent, for example alcohol. It is as the tissue that is immersed in alcohol, and alcohol has replaced the water in the tissue, so the alcohol is also cleared from the tissue with the help of another medium which is called the clearing medium, and this helps the impregnation of paraffin wax, and also clearing is done to make the tissue clear and improve the microscopic examination. The clearing agent should be soluble with both the dehydrating agent and the embedding medium. It is important that the refractive index of the clearing agent is similar to the tissue, because it gives a clear appearance of the anhydrous tissue. The completely transparent tissue, this indicates that the tissue has been cleared from the alcohol. Selection of a clearing agent, it depends upon the type of the tissue, that either it is a large tissue or a smaller tissue, because the large tissue it takes more time than the smaller tissue. The type of processor it is used, either it is manual or automatic, and the processing condition, that what is the temperature within the medium, and the vacuum it is either created or not created. The speed of the removal of dehydrating agent, and the ease of replacement by molten wax. The safety factors, that it is either inflammable, and the toxicity level of the factor of the agent, and the cost of the clearing agent. What should be the properties of a clearing agent? The clearing agent with low melting point, it is easily and quickly removed by the molten wax. The clearing agent with high melting point, it takes more time to be removed from the embedding medium. And agent which have high viscosity have low penetration rate. The optimum time for clearing a tissue is important, because if we pose the tissue for prolonged time, that the tissue may become brittle and it may be easily broken, or it becomes more friable. The amount of clearing agent, it should be 40 times the volume of the tissue. Types of clearing agent, we have different types of clearing agent, the xylene, toluene, or the chloroform, the esters or the cedarwood oil. These are the different types of clearing agents which may be used for the clearing purposes. Xylene, it is the most commonly used and the most important. It is a clear and inflammable fluid. The small pieces, they are cleared very fastly, and it takes around about 30 to 60 minutes to clear the alcohol from the tissue. Toluene, it has also similar properties just like xylene, but it have slightly a slower mode of action. One important property of toluene is that it does not harden the tissue when it is exposed for very long time. Toluene is flammable and also a toxic agent. So these are the drawbacks of the toluene. This is the comparison among the different clearing agents which are used in the laboratory for clearing the alcohol or dehydrating agent from the tissue. The properties are shown as the hardening of the tissue, the shrinkage of the tissue, the inflammability of the solution, what are the harmful or corrosive effect, or the expansiveness of the agent. So these are the certain properties on which the different agents they are compared with each other. This is the summary of the clearing process, that the aims of the clearing process, what should be the ideal properties of an ideal clearing agent, and how to select an appropriate clearing agent, what should be volume of the agent, the total duration, the end point detection, and what are the disadvantages if the tissue is exposed for a long time, and the different clearing agents which are used in the histopathology laboratory for clearing purposes and tissue process. The infiltration and embedding, it is the stage after the clearing, in which in the clearing stage the tissues, they are cleared from alcohol, and that alcohol is replaced by xylene. So after clearing, the tissue species will now be infiltrated with the embedding medium, and this clearing agent is removed by the process of diffusion. That xylene, that is replaced and by placing it in an embedding media. The embedding media is usually a molten wax. The wax is cooled at room temperature and solidified. This solidification supports the cutting of the tissue into thin section with the help of microtome. The time duration and the number of changes that is required for impregnation, it depends upon the size of the tissue. The thicker and larger tissues, they take more time and contains more clearing agent to remove. That's why the infiltration and embedding, it depends on the size of the tissue and also the type of the tissue. The hard tissues, for example the bones, the cartilage, they takes more time for embedding, and soft tissues, they takes short time. And also the clearing agent, it also have effect on the infiltration and embedding, because xylene and toluene, they are easy to remove from the tissue, and cedarwood oil, it is viscous as compared to xylene and toluene. It takes more time to remove the cedarwood oil from the tissue during the infiltration and embedding. The types of processing also depends. The vacuum embedding, that enhances impregnation, so it takes short time, while the normal embedding, when vacuum is not created, it takes long time. The qualities of an ideal impregnating medium, that it should be soluble with the clearing agent, that is xylene, cedarwood oil, toluene, or any other clearing agent, and it have a liquid property at higher temperature, and when it is cooled at room temperature, the impregnating medium become solidified. The impregnating medium, it should be homogeneous and stable. Also, it should be non-toxic to the tissues as well as to the lab personnel, and it should be cheap. It should be transparent, because when it is not transparent, that it may hinder in the staining process, and also it may hinder in the microscopic examination. It should be fit for the sectioning of the tissue. Usually the impregnating medium is paraffin wax, which is a hydrocarbon and produced as a byproduct during the refining of the crude petroleum. Universally, it is very popular for the impregnating and for the embedding during the tissue processing. It is a very cheap medium and a non-toxic. The melting point of paraffin wax, it varies from 39 degree to 70 degree. It have the advantage that we can store the tissue block for a longer period of time, and it does not have any effect on the tissue. It is cheap and very safe. The disadvantages of impregnating medium, that when a tissue is placed in impregnating medium for a long period of time, it becomes hardens and the tissue becomes shrink. So the tissue should be placed in the impregnating medium for optimum time. The bones and the eyes, the hard tissues, they take long time during the impregnating. So these tissues should be kept in the medium for long time as compared to the soft tissues. This is the whole scenario of impregnating and the embedding medium. The aims, the ideal medium, the duration and the difference in the embedding medium. Usually paraffin wax is used. Another embedding is dimethyl sulfoxide. It is also used. In the routine, the tissue processing is performed in such a way that in the dehydration process, first the tissues, they are placed in 70% ethyl alcohol for 1 hour, then it is changed into 90% ethyl alcohol for 2 hours. Another 90% ethyl alcohol is also there, so the tissue is brought to that in their jar for 2 hours. The pure alcohol also have two changes. Both the changes, the tissue is placed for 2 hours. In the clearing stage, the xylene also have two changes, and both changes in both changes 1 hour is required. The tissue should be placed in the xylene for 1 hour in each jar. The third stage of tissue processing in the routine, that is the wax impregnation, in which two changes are present of paraffin wax. In the first jar, we put the tissue for 2 hours and also for 2 hours in the second jar. So that is the tissue processing is completed in the histopathology lab. So what are the tissue processing methods that is performed in the laboratory? It can be done manually or by the automatic processor, and almost everywhere automatic processor is used. The principle of automated tissue processor is to transfer the tissue in various fluids and various solutions for a specified period of time in a desired and specific environment. We have two different types of tissue processor. The first one is the tissue transfer processor and the second one is the fluid transfer processor. In the tissue transfer processor, the buckets of tissue that is transferred from one container to another container after a specific time, and each container have different solution. The tissue basket is first immersed within the specific container for a specific time and then transferred to the next container automatically after processing in their jar. Within each jar and within each container, agitation is created by slightly swinging or by the rotation movement of the tissue basket. The time schedule and transfer of tissue in each container is managed and programmed by a microprocessor which is present inside the tissue transfer processor. The fluid transfer processor, it is a completely closed processor in which the tissue is kept in the container, which is periodically and timely filled with the different solutions. After a specific period, the fluid is poured from the container and the same container is filled with another fluid which is required for the next step. And this kind of processor, each step can be customized for vacuum, for temperature and for time duration. It have the advantages over the fluid transfer processor that the vacuum inside the system, it makes the tissue processing very faster and efficient. And in this system, the tissue does not dry. The chances of tissue drying is very less. The manual tissue processor, tissue is processed manually in the routine laboratory very rarely. It have the advantages over the automated processor that when the tissue are in small number, the samples are in small number, so they can be processed in small laboratory, and a person can carefully monitor each step. In case of emergency, when automatic tissue processor is not working, so we can take help from the manual processing. And in this system, we can select our reagent of choice, and we can set our time and the type of tissues. The major disadvantages of manual processing is that it is always not possible to perform manual processing. It is very inconvenient and cumbersome process, and it takes a lot of time to perform tissue processing manually. What are the precautions which should be taken during the processing of tissue? The amount of tissues, it should be suitable for the adequate penetration of the fluid, and the amount of the fluid, it should be adequate, and the fluid level should be higher than the tissues level which are immersed in the fluid. And the basket and cassette, they should be clean, and the basket should not have any spillage of wax. The temperature of the impregnating medium, it should be optimum, and it is preferable to keep the temperature slightly above the melting point. That if in case the melting point is 60 degree, so it is kept on 63, 64 or 65 degree. The stock record should be maintained for the change of the fluid, for the number of tissue process, for the time of tissue processing, for any specific kind of tissue. So all these should be recorded in a specific record register. The different problems that comes in tissue processing, that the softening of the tissue, the coming out of tissue from the block during sectioning, the micro chattering effects around the edges of the tissue sections, the cracked and folded tissue sections, irregular staining of H&E, and brittle tissue after processing. So these are the different problems that comes during the processing of the tissue, and their causes, and what are their remedies, and how to remove these problems. So all these are written in this section. That was all for today's lecture. Hope you have learned much more about the processing of tissue in the histopathology laboratory. Till next lecture, Allah Hafiz.